today we will discuss about linear regression. Linear regression is one of the most simplest and popular methods when you come to learning machine learning actually. And this is very this is very easy to understand. So I will also try to make it easier for you guys. So let's start. So linear regression is a combination of two words, linear and regression. Linear means that in a straight line, arranged in a straight line, extending in a straight line. So, and regression means that we want to determine the statistical relationship between two or more variables uh, in such a way that if we change one variable, it can cause change in another variable as well. So this is the simplest of the definition. So if we combine these two terms, linear and regression, so we can say that it can determine a relationship between two variables when an increase in one variable impacts another variable in a proportionately or in a linear way. So, in simple words, we can say that okay, if I speak in Hindi or Urdu, so in simple words we will say कि दो या दो से ज़ायद वेरिएबल्स के दरमियान जो रिलेशनशिप है एक स्ट्रेट लाइन में जो प्रेजेंट हो सकता है तो वो लीनियर रिग्रेशन होगा. So let's go through some basic terminologies first. There are certain terminologies which are very crucial to this topic and every other topic, in fact. So first one is independent and independent variable. Dependent variable is the variable or value that is predicted that we use predict, and independent variable is the variable or value that we use to predict डिपेंडेंट वेरिएबल. सो जो वैल्यू हम यूज़ करते हैं किसी की को किसी दूसरी वैल्यू को प्रेडिक्ट करने के लिए उसे इंडिपेंडेंट वेरिएबल कहते हैं और दूसरे जिस जो प्रेडिक्ट होती है उसको डिपेंडेंट वेरिएबल कहते हैं. जस्ट टेक एन एग्जांपल हेयर that temperature is directly proportional to the number of ice creams purchased. So as the temperature increases, the number of ice cream purchased would also increase. Here the temperature is independent because temperature is not depending on anything, so it is being used for predicting the number of ice cream purchased. So here the number of ice cream purchased is the our dependent variable. Second important concept here is correlation. Correlation is very important because in linear regression we are actually correlating things or establishing a relationship between the different variables. So first we want to establish that there is a relationship existing between the two variables or two or more variables. So for example, we say that in ice cream and temperature example, we say that okay, ice cream purchases are directly correlated with temperature. So in this particular case, the correlation is positive because as the temperature is increasing, the ice cream sale is also increasing. So in other cases, like correlation could also be negative. For example, if an increase in one entity is decreasing the other entity, so that will be called as negative correlation. So this correlation means that you want to establish that whether a relationship is existing between the two variables, two or more variables. So in Urdu Hindi, if I say that कि दो या दो से ज़्यादा वेरिएबल्स या वैल्यूज़ के दरमियान रिलेशनशिप है कि नहीं है, मतलब एक दूसरे को वो इम्पेक्ट करती हैं या नहीं करती हैं. So this is the story here. And then very important concept is causation. Causation is actually like who is impacting who. So that means that if we take the example of ice cream purchase and temperature, so if we say that okay, the ice cream sales increases as the temperature increases, so this is a positive correlation. But if we flip this statement and we say okay, as the temperature is will increase as the ice cream sale increases, so this is also a positive correlation. But is that second statement true? The answer is not, because temperature is not controlled by the uh, ice cream sales in any place or any way in the nature. So temperature is completely independent variable and it is not depending on any other factor, particularly this factor actually, ice cream sales. So causation, what is causing, who is causing causation is very important here. Then simple and multivariate linear regression. If we are establishing relationship between two variables, then it is simple correlation. And if there are more than two variables, then we will say that this is multivariate. Like in this the example above, temperature is not the only thing that influences or affects the ice cream sales. There can also be price of the ice cream as well, location and brand of the ice cream, and many other factors as well. So this is the between simple and linear regression, multivariate linear regression. So how we write this linear regression? Simple is y is equal to a plus b into x. Here y is the dependent variable, x is the independent variable. That is the value we know about this. We use this value of x to predict y, and a and b are the bias and slope in this particular equation. And these you can also say that these are our coefficients in this particular case. So y and x are our variables, and a and b are our coefficients. A is terms as bias. What is bias actually? Bias is we can take simple example that we it is something as a word shows that we begin with. We begin with let's say um, if we say that okay, we want to estimate the weight of the baby by the age in its age in months. So that means that we have to get a starting point. So let's assume that if someone is just born, so what would be the weight of the baby? Let's say it is 3 kg, and it is now increasing at 0.75 kg per month. So in this particular study, if we look at the figure, at the 0 month, it was at 3 kg. So it is increasing, and after every month, it is increasing by the rate of 0.75 kg per month. So here, the 3 kg, which we estimated as the initial starting point actually of our relationship or regression. So this is our bias. And similarly, slope, or which is our second factor in that equation, is the difference between the extremes of y coordinate and x coordinate, which in this particular case is 0.75. So these are both coefficients, and you can change these coefficients as well. That depends actually what is the problem in your hand as well. What you cannot change is the variables you have, because these will be the real world values obviously. So once we go through this factor, so we can we will get this kind of table, that okay, this should be the scenario here when we are taking the example of 18 months and weight in kgs. So okay, so this is the ideal scenario, and this is but in real world it is not the case actually, you know about that. So if we put that in our equation, this is very simple. When the it is 0 month, and a is 3 and b is 0.75, the age sorry weight in kg will be 3, because it become this thing becomes 0. And similarly, because it is increasing by the rate of 0.75, so because a is equal to 3 and b is equal to 0.75 though, so it eventually it will be increasing, and this table will be generated in the end. And you can see that this is the our actual, and this is our estimated. And if we calculate the some error in it, we consider the scared error, so it will be 0. Overall scared error will be 0. So this is the ideal situation actually, but in real world it is not happening. So we in the real world we expect that there would be some difference between the age of different between the ages and weight of the babies. So let's say there will be a baby who has a okay, let's say initial weight of 3 kg, but in the subsequent months it is not increasing at the rate of 0.75 kg. It may be more than 0.75 kg or less than 0.75 kg. So that means there will be always be a variation, so we should always expect that. So in this particular case, for example, if you just look at this particular example, we have varied a and b, which are our coefficients, to the least of the possible values like 2.99995, and similarly b is instead of 0.75 is 0.750002. So you can see um, the difference between actual and predicted estimated value. So the difference, there will be obviously a difference, and eventually it will lead to some error. So this is our overall error. That means there is error which was in previous section. In previous scenario it was 0, but now we have error for even the smallest of the changes. Similarly, you can see if we just look at this figure, which seems to be very minute, very small, but still there will be error. So the big question here is how to come at the ideal number of coefficients, because everything that is depending on this value of a and b, the value of coefficients. So what we can do is that we can try some simple techniques like gradient descent. It will also be discussed in the coming lectures. So what we do actually, we randomly initialize the values of a and b, and calculate the cost function that is the sum of scared error. If your error is you just alter that by 1%, change the value of coefficients by 1%, and if from the initial point your error is increasing or decreasing, that will change the course of your action. If your error is decreasing by changing the value of coefficients by 1%, then proceed further and reduce the coefficient by 1% more. Eventually, after several iterations, you will be able to reduce the error to its minimum, and those will be the ideal values of a and b in your case. So this is how it works, and yeah. So I guess stay tuned for the more videos. Next, we will see multivariate linear regression, and like, subscribe, and share my channel. Thank you. Bye bye.